All right, so yesterday when I did my recording, I realized that I hadn't shared this screen, and all you hear is me talking. You don't see the problem. So I am going to redo this problem for you so that you can have an example of how to do a sampling distribution. Sampling distribution for a sample proportion, just section 8.2. Okay, so the National Association of Realtors estimates that 23% of all homes purchased in 2004 were considered investment properties. If a random sample of 800 homes sold in 2004 is obtained, what is the probability that at least 175 homes are going to be used as investment property? Okay, so we have to go through and we have our population proportion, which is 0.23, because out of all the homes, 23% of them were investments. Okay, but then we have a random sample, so my n is 800. That's how many sample, or my sample. That's my sample size. Okay, so because I have a sample, I need to go through and find my mean of my sample proportions, and I need to know my standard deviation of my sample proportions, because if I had chosen a different 800 homes, I would have had a different sample proportion. So we have our formula that the mean of our sample proportions is just our population proportion, so it's going to be 0.23. Our standard deviation of our sample proportion is going to be the square root of p times 1 minus p over n. Okay, so it's going to be the square root of 0.23 times 1 minus 0.23 all over 800, which when you do this, sorry, it's 0.23 times 1 minus 0.23 divided by 800 and the square root of that answer, and you will get about 0.015. Okay, so we want to know the probability that at least, so we're going to have that my sample proportion, because that's what I'm looking at, is sample proportions, is at least, so it's just greater than or equal to 175 homes. So 175 homes isn't a proportion. Proportions are between 0 and 1. So my p hat is going to be my number that have that quality divided by how many are in my sample. So it's going to be 175 over 800. Which in this case is 0.21875. Okay, so in some problems, you are given sample proportion for you, and sometimes it's given to you as how many were be this different characteristic, and you got to go through and find the proportion of that by doing the how many divided by how many total you had. Okay, make it a proportion. So I want to know that the proportion is greater than or equal to, the probability of the proportion, sample proportion, is greater than or equal to 0.021875. So we have this distribution of p hats, okay? And it is normal because np times 1 minus p, which is going to be 0.23 times 1 minus 0.23 times my n, which was 800, equals 141.68. And so that means that my NP times 1 minus P is greater than or equal to 10 because 141.68 is greater than 10. So we can go through and utilize our normal distribution up here. So we have our mean at 0.23. Then I'm going to have 0.23 minus 0.015 and have 0.215. I minus a 0.015 again, and I have it as a 0.2. So I went through and I standard deviation increments down so I can just kind of get a feel for it. But I want to know if it's less than 0.218. So 0.218 is like right there. Somewhere between 0 and 1 standard deviations away. Okay, so now I'm going to go through, and because I can use the normal distribution, and I want to find this probability, I'm going to find the probability, meaning that normal CDF of my lower, upper, mean, and standard deviation. So my normal CDF of my lower bound, which was negative infinity, upper bound was 0.21875, my mean was 0.23, and my standard deviation was 0.015. So I go to my calculator, and I go to second vars, go to normal CDF. My lower bound is negative 1 times 10 to the 99th, which is, in all intents and purposes, negative infinity. My upper bound is 0.21875, excuse me, but you can type that, or you can just do the equation in your problem. So it's 175 divided by 800. Okay, then my mean is my mean of my sample proportion, which was 0.23. And then I wanted to go through, and you could put 0.015 in there, but that's rounding. And there's a chance that that rounding error will give you a different answer at the end. So if you can avoid rounding until the very end, that's going to be better for you. So I'm going to actually just go through and plug in 0.23 times 1 minus 0.23 divided by 800, and then close on parentheses because that's all underneath the radical, and then go through and I paste that, and I get 0.22, I didn't see what it said actually, 0.2248. Okay, and that is your answer. Okay, I just wanted to make sure that you had that example because when I looked at the video yesterday, you didn't see any of the work, and so I wanted to make sure that you had an example for your records. Okay, have a good day. Goodbye.